Hello and welcome to the Daily Space for today, September 20th, 2018. My name is Dr. Pamela Gay, and I am here to put science in your brain. Today is one of our special Thursday episodes where I'm going to do a quick rundown of the news, and then we're going to be joined by a fabulous guest, one of my favorite artists, Daniela De Paula. But before that happens, well, science keeps on sciencing, and we have new results coming at us from all directions. Now, I have to admit that today I don't have any pretty pictures to show you, but that doesn't mean I can't talk about the science. In our first news story of the day, I have more new awesome information coming to you from the Gaia spacecraft. This is a mission that is orbiting our Earth and taking, well, more accurate images of the positions and colors and brightnesses of the, well, stars it can see than has ever been taken before. Astronomers looking at this data and looking to understand stellar motions have been able to piece together, well, more science than anyone thought could be done quite this rapidly. One of the newest results is to start to be able to put a timestamp on when our galaxy last had a close encounter of the galactic kind. According to new results coming out of the European Space Agency, roughly 300 to 900 years ago, there was a close encounter between our galaxy and another galaxy. This particular encounter set up waves of stellar motions within our galaxy that we're still able to see. The way that they're looking at it is you can see what's called phase mixing between the different oscillations and waves and shell pattern, essentially, that got set up within our galaxy. These kinds of waves, they follow that grand spiral design, giving us, well, the kind of arms that have the same shape that you see crop up in nature, whether it be in, well, snail shells, the Fibonacci series, or sometimes even the pattern in your broccoli. It's amazing that we can now start to say what we're seeing, these standing waves within our galaxy, they came at this specific time. It's cool that we're able to get detailed histories. Now, what's amazing about this particular timeline is we're now able to say what happened on galactic scales within the time that, well, we understand the geologic history of our own planet. In lockstep with our geological and fossil records, we now have stellar records. We're writing out the history of our, well, nearby universe, one stellar motion at a time. Now, Gaia isn't the only amazing thing producing science right now. We also are getting, well, more data coming out of the European Planetary Sciences Conference that's taking place right now in Berlin. One of the more disturbing pieces of news is that you can use cotton candy pink lagoons here on Earth. These are lagoons that are extraordinarily salt rich and look well, not the way one would expect a lagoon to look. These very briny lagoons that occur in some places here on Earth are rich with life that isn't the kind of life that we're used to in, well, your normal everyday blue lagoon. In studying these high salt lagoons, there is new evidence for how life might have come into existence on Mars or Europa. On Mars, we have various, sometimes contradictory evidence that there may be, maybe isn't, briny, salty water just below the surface that sometimes comes out in black streaks that will flow across the surface of the red planet. If this is what we're seeing, briny, salty water on the surface, it means that any life that is adapted to exist on Mars has to be adapted to that super salty environment. By studying super salty water here on Earth, in this case, it comes in cotton candy pink by studying these pink lagoons. We're able to start to get a handle of what just could exist out there. It's always amazing to get more and more ideas of what could be out there by finding, well, similar environments here on the planet Earth. What's kind of amazing is they are defining different kinds of bacteria. They're finding sulfite-rich brines, for instance, have one set of bacteria. Those without the sulfites have others. We're building up a specific picture of what can exist in different environments. Now, continuing to look, there is actually more coming to us about black holes. It looks like if you measure the rate at which material can fall into a black hole before disappearing over the event horizon, matter has the ability to reach 30% the speed of light. In new results coming from the United Kingdom, astronomers are able to report that the distant galaxy PG 211 plus 143 has material in it that has been accelerated to this amazing velocity. This is work that is being led by Ken Pounds at the University of Leicester. This is just one of those cases where using the XMM Newton telescope, it's an X-ray observatory orbiting our planet, to observe the black hole, they were able to get new observations that, well, hone in on just how fast, how much energy is involved in, well, feeding that black hole material. So we now know just how fast stuff can get going, and the answer is 100 kilometers per second. This isn't a huge science result. We knew things got going fast. This is just sort of a, wow, that's cool result. But by measuring more and more supermassive black holes, by measuring the velocity of more and more material as it flows in, it starts to allow us to build a picture of how do different feeding black holes behave. And isn't it cool that stuff can go 30% the speed of light? So that's a quick roundup of what's going on in space science.